Well, we have another question here, question 8. The question says determine f prime of x, okay, from the first principles if it is given that f of x equal to x squared minus 5. Now I'm gonna write here 8.1. So f, we're looking for f prime of x from the first principle, okay. The first principle is given when f prime of x is equal to the limit of f of x plus h minus f of x, I mean, over h, and then h approaches 0. Now, f of x plus h will be, means that wherever we have x, we're going to substitute x plus h, so that makes x squared, minus 5 like that. So over here I'm gonna write x plus h. So this will be equal to what? X plus h times x plus h minus 5, okay? So we're going to do x times x times h times x, h times h. And then this will make equal to x times x makes x squared, x times h makes xh, and then h times x makes xh, h times h makes makes h squared minus 5. Now we can write here f of x plus h equals to, we can combine like terms, that makes x squared plus 2xh plus h squared minus 5, okay? And then f of x was given by x squared minus 5, okay? So what I'm going to do here is we're going to work out the numerator. First of all, we did work out f of x plus h. Here it is. And then done. Now we're going to work out this numerator here, f of x plus h minus f of x. So we can just complete the missing side, the missing places by zeros. Now let's simplify. X squared minus x squared would fall, and then negative 5 minus 5 will also fall, because we'll have like negative 5 minus makes plus, so negative 5 plus 5 it's 0. Then the difference here between of f of x plus h minus f of x is just equal to 2xh plus h squared. Okay. Then let's divide both sides by h, because I need to work out this fraction here. Okay, we'll divide by h over h, and then over h. There we'll have, this will be like f of x plus h minus f of x, okay, over h. This will be equal to, if I take h as a common factor, this will be h open bracket in the bracket like that, and then I write 2x plus h over h, and then we can simplify the h's, like we can cross the h's out, and then we have left with 2x plus h. So this is equal to 2x plus h, right? Now the next thing is to introduce the limit, okay, and h approaches 0. So this will be like the limit of this function, h approaching 0, of f of x plus h minus f of x all over h will be equal to the limit here, this limit h approaching 0 of 2x plus h. So this simply means wherever we have h, we're going to substitute by 0 there. Just then is the derivative. Okay, I can just write it over here. this is all this on the left hand side is the derivative that's form f. That makes like f prime of x, and then when we sub in 0 there, we have this is equal to 2x. So f prime of x is equal to 2x. That was f from the first principle. Now question 8.2. Now that was 8.1 and now 8.2. The question says determine dy dx if we have like 8.2.1 says y equal to 3x cubed plus 6x squared plus x minus 4. Okay, in this situation, remember we're going to, it's a polynomial, we're going to differentiate each term, okay, following the formula I'm going to write here. 8.2.1, what we have y equal to, so we're looking for dy dx is what we're looking for, and then y is given by it was 3x cubed plus 6x squared plus x minus 4. Now to differentiate a function, you have like a x to the power of n derivative. This is same as n times a times x to the power of n minus 1. Now I want to differentiate each term of this function. So I want to do like dy dx will be 3x cubed derivative plus 6x squared derivative plus x derivative minus 4 derivative. So this will be like over here a is 3 and then n is also 3, so this is going to be like 3 times x to the power of 3 minus 1 plus 2 times 6 times x to the power of 2 minus 1. Over here a is 1, the coefficients, and then exponent is also 1. When you don't see them, it's like that. So plus 1 times x to the power of 1 minus 1. And then the derivative of any constant is just equal to 0. So over here, minus 0. And then this will be what? 9x squared plus 12x. Okay, 1 times 1 times 1 makes just 1. So that makes plus 1. That's the derivative of the given function. Okay, and then the following question is question 8.2.2. I want to do it, let's just do it over here. (8.2.2). What does it say? Oops. It is say that yx equal to, okay, yx minus y equal to 2x squared minus 2x, and then x is not, it is different than 1. Okay, it looks a bit different, kind of tricky. Now we're looking for dy over dx, okay, of what? Of yx minus y equal to 2x squared minus 2x, and then the condition is that x is not equal to 1. Now in this situation, this is what, how can we do that? Okay, sometimes it's tougher to work out the function, to differentiate the function like that. We're going to transform the function, okay? So we have like, I can see that we have y here and then y there. We can take y as a common factor, okay? So it's gonna be like y, okay, in the factor like that. We will have left with x minus 1 equal to 2x squared minus 2x, right? So we can now also divide both sides by x. minus 1, and we divide by x minus 1. And then this is valid because they tell us x is different than 1. Because if x was 1, we couldn't divide by x minus 1 because 1 minus 1 will make 0 here. Division by 0 is ruled out. So we can do this and then simplify here. And then we are left with y equal to 2x squared. Okay, over here, let's also take common factors. We have like, we can take 2x as a common factor, okay? 2x, the common factor, the highest common factor. So it will be like x minus 1 over x minus 1. There also, we can simplify these two. And then we have left with y equal to 2x. Now, the derivative of this following this formula here, okay, this formula, you notice that the exponent is just 1, okay? So we can just do y equal to 1 times 2 times x to the power of 1 minus 1. That makes y equal to 2. You know, 1 minus 1 here is 0, okay? So it's going to be like 1 times 2 times 1, which makes actually the derivative now. That's the derivative, okay? That dy dx. So 1 times 2 times 1 dy dx d dy dx equal to just 2. So that's the derivative. Thank you.